Hi, boys and girls. Okay, we're going to deal with limits at infinity. You're going to see limit as x approaches infinity or limit as x approaches negative infinity. And this is going to indicate, are we going to have a horizontal asymptote? And there are basically three rules if you're dealing with a rational function. If you're dealing with a rational function, is it top heavy? What I mean by that is the exponent on the top bigger than the exponent on the bottom, or is the degree of the top bigger than the degree of the bottom? If that is true, if it's top heavy, then the limit does not exist. The second example would be if they are even. In other words, if you had like an x cubed over an x cubed. If that's the case, then the limit is the ratio of the leading coefficients. And the only other possibility, if it's a rational function, is if it's bottom heavy. For example, if I had like an x squared over an x to the fifth. If it's bottom heavy, then the limit is 0. Okay, let's go through and look at some examples of what I'm talking about. Here I've got the limit as x approaches infinity, and I have a rational function. Now the degree of the top is x to the first, and the degree of the bottom is also x to the first. This is what I would refer to as an even rational function, because the top and the bottom have the same degree. So in this case, it's the ratio of the leading coefficients. Here's the leading coefficient on the top. Here's the leading coefficient on the bottom. The answer to this is 2 over the 1. 2 over the 1. That's funny. 2 over 1. If you were to look way out on the x-axis to the right, this graph would just settle down to like y equals 2. That's what it would look like way out to the right as x approaches infinity. Let's look at another example. This one is going towards negative infinity, so we still want a horizontal asymptote, but here we want to look way out to the left, out here towards negative infinity. Again, I've got something that's even. I've got an x to the first over an x to the first, and so this answer is the ratio of those two coefficients. The minus 7 doesn't really matter because x is getting ridiculously big in the negative direction. So 5 times a great big number, and then minus 7 doesn't really matter. Great big negative number, I mean. So this answer is 5 over 1. Now look at this. Oh my goodness gracious. I've got an x to the fourth on top, x cubed, x squared, and x1. But this is still a fourth degree polynomial on top. And the bottom is also a fourth degree. As x approaches positive infinity, this other stuff doesn't really matter because what gives the power to the top and bottom is the x to the fourth. It's the degree. So our limit as x approaches positive infinity is the ratio of these coefficients, since that's even, and so that would be 5 to 4. Now what about this one? The bottom is like factored, so let's take a look at what would happen if we were to multiply this back out. We would get x squared minus x minus 6. Now I've got a rational function here looking as x approaches positive infinity, but the problem here, well, not really the problem, but the situation here is I've got an x to the first on top and an x squared on bottom. This is bottom heavy. That means as x gets really big, the bottom's going to outgrow the top, and so you're going to get a great big number on bottom. And what happens is this is going to approach 0 because the bottom gets so much larger than the top does. So that answer is 0. Okay, let's take a look at something that's like a square root, because that's the only time you got to be careful. So we want horizontal asymptotes, so I want the limit as x approaches infinity, and I also want the limit as x approaches negative infinity. Now let's take a look at this simplified. Forget the plus 9 because as we're looking way out to the right on the x-axis, that plus 9 doesn't matter. This would simplify to 4x over the square root of x squared, which is 4x over the absolute value of x. Because the absolute value, because this square root will always be positive. Now as we're approaching infinity, that's basically an x to the first over x to the first, and so that matches. So if we plug in a great big number, those x's would cancel and it would be 4. But you got to be careful when you're approaching negative infinity here. If I'm approaching negative infinity, the numerator is going to be a negative number because we're plugging in a big negative value for x. But what's that bottom going to be? This bottom's going to be positive because when you do the square root of x squared plus 9, you're going to get a positive number, but we get a negative one on top. So that's the only time you really have to be careful. That answer is going to work out to be negative 4. So I have two horizontal asymptotes. So this thing does something like this. Actually has two of them. One down here at -4 and one up here at 4. So that answer is C. I will see you guys tomorrow.